Today I will be talking about GIS and natural resource management. What is natural resource management? It is the management of natural resources such as land, water, soil, plants, and animals with a particular focus on how management affects the quality of life for both present and future generations. Natural resource management deals with managing the way in which people and natural landscapes interact. It brings together land planning, water management, biodiversity conservation, and the future sustainability of industries like agriculture, mining, tourism, fisheries, and forestry. It recognizes that people and their livelihoods rely on the health and productivity of our landscapes, and their actions as stewards of the land play a critical role in maintaining this health and productivity. There are many federal and state agencies, tribal organizations, non-governmental organizations, private industry, nonprofits, special interest groups, and educational institutions involved in natural resource management in some way through lobbying, research, actual management actions. Why must we manage our natural resources? For economic, social, and cultural viability. Many countries, states, communities' viability is dependent on certain natural resources. Think of the communities that support miners and loggers, fishermen and crabbers, outfitters and guides, and those communities that surround national parks. Resource sustainability, not only so that the communities just mentioned will continue to thrive, but so that the resource will be present for future generations. Resources must also be kept available for other species, as humans aren't the only ones to benefit. Tracking how resources have changed over time can help direct management efforts. As we learn more about climate change, management tactics must be modified. As the human footprint on the planet grows, human-wildlife conflict will only increase, and we must do what we can to mitigate it. I just wanted to share this slide to show that GIS remote sensing technology have been used for many years. During World War I and II, airborne remote sensing was used for reconnaissance and mapping. In the 1950s, we began using spaceborne satellite remote sensing for military and meteorological applications. We now have 43 years of global 30-meter resolution multispectral imaging from the Landsat program. In the 1970s, the now president of Esri, Jack Dangermond, started working on Odyssey, the genesis of ArcGIS, and ArcInfo became widely known in the 1980s. In the 1990s, the first commercial airborne LiDAR system was used. LiDAR is more accurate land surface measurements and 3D modeling of the landscape. And now in the 2000s, there are many more Earth-observing systems used for such applications as measuring pollution, leaf area index, land use and land cover, and water properties. GIS is a powerful management tool. Natural resources are not uniform and vary spatially. Management efforts can vary drastically across the landscape depending on the footprint of the resource. Pre-project, you can use GIS data for site selection and creating field maps. Post-project, you can use GIS for answering questions related to proximity, coincidence, intersection, overlap, visibility, and accessibility. Use GIS to detect and quantify patterns in your data by finding statistical hotspots, outliers, and natural data clusters. You can also use it to analyze changes in patterns over time, do predictive modeling, and make measurements based on the size and shape of your feature of interest. To give you an example of how we can manage our natural resources better, we're going to talk about roadkill. Wildlife vehicle collisions are scary. How many of you have had one of those near-miss incidents where your heart jumped into your throat? So what's the big deal? Well, Westerners have become somewhat desensitized to seeing roadkill lying on the side of the road. But when wildlife vehicle collisions happen, they can become quite expensive really quickly. Luckily, there are a number of cost-effective ways to mitigate both the dangers and the monetary costs to humans and wildlife. In In the 2015 State Farm Deer Collision Facts, based on claims data and state licensed driver counts, 1.25 million claims filed over the last year due to deer collisions. The national cost per claim was just over $4,000, and the total cost associated with wildlife vehicle collisions across the U.S. amounted to nearly $8 billion last year. This cost includes repairs, medical bills, towing, law enforcement services, the monetary value of the animal, and the disposal of the animal. Roads are a huge net over the landscape that cause wildlife habitat fragmentation and travel corridor disconnection. They are comparatively more detrimental than other types of landscape alterations, like clear cuts, because roads are permanent with continual maintenance and disturbance. There are millions of vehicles traveling millions of miles on public roads, and we know that there is approximately 300 million animals killed every year, with about 1 million of those being deer. Here in Idaho, roadkill data can be collected from Idaho Fish and Game's Roadkill and Salvage webpage. On this webpage, you can find publicly available data collected by the public through observations, Idaho Fish and Game staff, and other agencies such as the Idaho Transportation Department. A couple of years ago, I worked with an Idaho Fish and Game biologist to study the density of mule deer roadkill incidents along a stretch of Highway 30 near Montpelier, Idaho. So I collected data from the Idaho Fish and Game Roadkill website and plugged it into my GIS to look for hotspots. The map on the left shows hotspots of roadkill incidents in his area of interest. The graph on the right shows the number of deer roadkill versus mile markers for one particular hotspot. You can see that there is a dramatic spike in incidents between milepost 443 and 447 for 3 different years. I exported the milepost data to Google Earth to investigate. This graphic gives you an idea of why there is a higher density of mule deer roadkills in this area. You can see that there are 2 fairly sharp corners with limited visibility on either side of a small set of ridges. The mule deer are also likely using the ridges as travel corridors and for moving from the ridges to the egg fields to feed. This looks like a great spot to put a highway underpass or overpass to reduce wildlife vehicle collisions. Here's an example of one of those underpasses. This particular underpass is on Highway 21 near milepost 18. It was completed in 2010. Not only does it have a wildlife underpass, but there are 1 to 1.5 mile wildlife fences on either side used for funneling deer and elk off the road to the underpass, and it has been estimated that 80% of deer and elk now use the underpass instead of going over the highway. Just a final thought. Successful management implies continuous learning, so keep on learning.